All right, let's just jump right in. You've got an iOS interview breathing down your neck, and you need the absolute essentials, and you need them fast. So think of this as your own personal high-speed cram session. We're going to cover the stuff that you are almost guaranteed to be asked about. Feeling that pressure? Yeah, don't worry. I've been there. We've all been there. But here's the good news. A handful of topics come up over and over and over again. If you can master these, you're going to walk into that room with a huge confidence boost. So here's our game plan. We are hitting the 4 foundational pillars of iOS development. We're talking about getting data, structuring your data, dealing with data that might be missing, and writing code that's super flexible. Let's get to it. First up, networking. I mean, think about it. Almost every single app you use needs to talk to a server, right? It needs to grab user profiles, product lists, you name it. Understanding this whole flow is completely non-negotiable for an iOS developer. You know, at its core, this whole process is actually pretty straightforward. When your app asks a server for information, it usually gets it back in a format called JSON. Just think of JSON as the universal language of the internet. It's all built on these simple key-value pairs. For example, username would be the key, and Sean Allen would be the value. Simple as that. The whole thing really breaks down into just 3 simple steps. First, your app makes a GET request to, get that raw JSON data. Then it decodes it. Now, this is the magic step where that block of text gets turned into a native Swift object that your code can actually understand and work with. And finally, you display it, using that new object to fill out the screen. Get, decode, display. You will see this pattern everywhere. Okay, let's roll into our next big topic, which builds right on top of the last one. Once you have that data, how do you actually organize it inside your code? This leads us to one of the most classic all-time interview questions. So, what's the difference between a struct and a class? So, the real technical difference boils down to this. Structs are value types, and classes are reference types. What does that mean? Well, when you pass a struct around in your code, it makes a brand new, totally independent copy. But when you pass a class around, you're just passing a pointer or a reference to the one and only original. All arrows are pointing back to the same source of truth. But forget all that technical jargon for a second. Here is the killer analogy that will make this stick forever. Think of a struct as a Microsoft Excel file. If you email that file to me, I get my own separate copy. Whatever changes I make are totally isolated. They don't affect your original at all. A class, on the other hand, that's a Google Sheet. When you share the link with me, we are both editing the exact same document in real time. If I change something, you see it instantly. Okay, on to topic number 3. What happens when the data you need might not actually be there? You know, like a user profile probably has a username, but the bio field, that could be empty. Well, Swift has this really beautiful and safe way to handle this kind of uncertainty. It's called an optional. Honestly, the best way to picture an optional is as a closed box. When you receive one of these boxes, you have no idea what's inside. It might have the value you're hoping for, like the number of 41 for someone's age, or it could be totally empty. And in Swift, we call that empty state nil. And this is the most important question, right? Because if you just assume there's something in the box and try to grab it when it's empty, your app is going to crash hard. So Swift gives us these safe ways to peek inside before we try to use the value. We call this unwrapping. The most common way to do this is with if-let. It's basically like saying to the code, hey, if we can successfully let this temporary new variable age equal whatever is inside that user.age box, then, and only then, run the code inside these curly braces. If the box is empty, that whole block of code just gets skipped. No crash. And that new age variable, it only exists inside that if block. Now, the second method, and honestly the one you'll probably prefer a lot of the time, is guard-let. Think of guard-let as a bouncer at a club. It stands at the door of your function and says, you must have a value to get past me. If you don't, you have to leave right now. It's fantastic because it lets you exit a function early if you don't have the data you need, and it saves you from those deeply nested if statements. All right, let's hit our final core topic, generics. Now, this one's a little more advanced, but it's really what separates good code from great reusable code. Generics are all about writing functions and other types that can work with a whole variety of different data types, not just one. the main reason we love generics, it's all about eliminating code duplication. I mean, instead of writing one function to sort an array of numbers, and then another one to sort strings, and a third one to sort dates, you can write one single generic sorting function that works for all of them. It's about writing less code that does more work. Here's a really great way to think about it. Imagine you're writing a function called drive home. You don't want to write a separate drive home function for a car, and then another one for a truck, and a third for a motorcycle, right? No way. Instead, you write one generic function that can take any vehicle with one condition. That vehicle has to be drivable. It has to have an engine and wheels. The function doesn't care if it's a car or a truck. It only cares that it has the capability to be driven. That is the power of generics. Whew. Okay, we have covered a lot of ground really fast. So let's lock all this knowledge in. Let's pull up a final cheat sheet to tie everything together perfectly. This right here is your golden ticket. For networking, just remember, JSON is the language of the internet. For structs versus classes, it's that Excel versus Google Sheets analogy. For optionals, picture the closed box that might be empty. And for generics, think of that single function that works for any drivable vehicle. Trust me, these analogies are going to be your best friend in that interview. So there you have it. 4 fundamental concepts, 4 really memorable analogies. You're not just ready to answer the questions anymore, you're ready to explain them with real clarity and confidence. Now go get them.